Can you factor polynomials with multiple variables? Imagine trying to solve a puzzle where each piece has more than one shape or color. Factoring polynomials with multiple variables is just like that. It might seem tricky at first, but with the right approach, it becomes manageable. When you see an expression with more than one letter, like x and y, it's called a multivariable polynomial. These are made up of terms that include variables raised to whole number powers, combined with addition or subtraction. For example, an expression like 6x squared plus 12xy minus for x minus 8y is a multivariable polynomial. Factoring these expressions follows many of the same ideas as factoring single variable polynomials. The first step is to look for the greatest common factor among all the terms. This is the biggest number and set of variables that divide evenly into every term. For instance, in 6x squared plus 12xy minus for x minus 8y, the GCF is 2. Factoring out 2 gives us 2 times 3x squared plus 6xy minus 2x minus for y. Next, you can try grouping terms. Grouping means putting terms that share common factors together. For example, in the expression I just mentioned, you can group the first 2 terms and the last 2 terms. So you get 2 times 3x squared plus 6xy minus 2 times x plus 2y. Now, look inside each group and see if you can factor further. In the first group, 3x squared plus 6xy, you can factor out 3x. That leaves you with 3x times x plus 2y. In the second group, you can factor out minus 2, which leaves you with minus 2 times x plus 2y. Now, notice both groups have the common binomial x plus 2y. You can factor that out, and the entire expression becomes x plus 2y times 3x minus 2. Factoring trinomials with 2 variables works similarly to single variable trinomials. You look for 2 binomials that multiply to give the original expression. For example, the trinomial to x squared plus 7xy minus 15y squared can be factored into 2x minus 3y times x plus 5y. You find these binomials by trial error and checking their product. Reverse FOIL, or the process of guessing 2 binomials and multiplying them to see if they match the original, is also useful. You try different combinations until you find the right pair. When working with multivariable polynomials, these methods help you break down complex expressions into simpler factors. Remember, always start by checking for the greatest common factor. If you find one, factor it out first. Then, try grouping terms or using trial and error to find binomials. For higher-degree polynomials, methods like the AC method can help, which involves multiplying the coefficient of the first term and the constant term to find possible factors. Factoring multivariable polynomials is a helpful skill because it makes solving equations easier. It also helps you understand how these expressions behave when graphed or used in real-world problems. For example, factoring expressions like 8x minus y cubed plus for xy squared minus 2y can be done by grouping. First, group as 8x plus for xy squared and minus y cubed minus 2y. Then factor each group. For x times 2 plus y squared minus y times 2 plus y squared. Now you see the common binomial 2 plus y squared, which you can factor out. The final factored form is 2 plus y squared times for x minus y. So yes, you can factor polynomials with multiple variables. It just takes a bit of practice to recognize common factors, patterns, and the best methods to use. With patience, these techniques become easier, and you'll be able to handle more complex algebra problems confidently.